Hi, welcome to this class, and in this class we will talk about the manometers. Okay, now I have made these notes before this lecture, so let's see. Now, what are manometers? Manometers are pressure or pressure difference measuring devices in fluids. So with the help of manometers you can measure two things. Okay, either you can measure the pressure in a fluid, or you can find the pressure difference between two fluids. Okay, like you have a pipe here and you have another pipe here. Okay, now these two have fluids in them. Now if the pressure is PA and the pressure is PB, you can find PA minus PB or PB minus PA, or you can just find pressure at A, okay, this pressure, or you can also find this pressure at B with the help of manometers. Okay, that's what is the use of manometers. They just use to find the pressure or the pressure difference. Now manometers are of two types. Okay, now one type is simple manometers and the second type is differential manometers. Now the first one, simple manometers, it is these, they are used to find the pressure at one point. Okay, like PA here or PB. Okay, these are pressures in at one point, right? PA is, let's say this is A point and this is B point, so PA is pressure at A point and PB is pressure at B point. You can find any of these pressures, but the thing is that you can find pressure at one point using simple manometers. Okay, so simple manometers means what? Pressure at one point. Now differential manometers, as you can see this word differential means difference. So with the help of differential manometers you can find the difference of pressure between 2 points, like we have said here, PA minus PB or PB minus PA, between A and B. So differential means difference of pressures between 2 points, and simple are just only for pressure, to find pressure at one point. Okay, now again the simple manometers are of many types, like A is piezometer, B is U-tube manometer, C is single column manometer, or we also call it as SCM. Okay, and the differential manometers are of, mainly they are of, basically they are of two types: U-tube differential manometer and inverted U-tube differential manometer. This is here U-tube, inverted U-tube differential manometer. Basically these two are the same almost. Okay, now here we use a U shape. Okay, but here we use inverted means upside down. We use this manometer. Okay, anyways we will go through them one by one. Now let's first begin simple manometers. Okay, now the first type in the simple manometers is piezometer. Now what is this piezometer? I have written here, it is the simplest form of manometer. All right, this is very simple, used for measuring gauge pressures. Okay, on one end of this manometer is connected to the point where pressure is to be measured, and other end is open to atmosphere as shown below. Now see, there are 2 points. Basically an inverted, this piezometer is like something like this. Let me draw like this. Okay, it's like continuous. Okay, now this is the piezometer, just this. Okay, just this. Now you can connect it to a water pipe. Okay, like this is the cross section. This circular thing is the cross section of the pipe. You attach it one end. This have, say, this is end 1 and this is another end, right? This is end 2. Now you connected this end 1 with the pipe, right? Like this, as this is shown here. Okay, so you connected one end to the pipe and another end, look at here, another end is free to the atmosphere, right? That's why I have written here one end of this manometer is connected to the point where pressure is to be measured. We have connected this end with this pipe. Why? Because we want to find pressure in this pipe, in pipe A. Okay, we want to find pressure here, so that's why we connected this end, one end, to this pipe. And now the another end, end2, right? Now here is air, of course, right? This is open to the atmosphere here, open to atmosphere. That's why I have then written other end is open to the atmosphere. This is really very simple. So what is going to happen? How it is going to measure the pressure? You see, when you connect this here to the pipe, right? Here is fluid, right? Now here is a small hole and you inserted this L shape, this piezometer, into this pipe. Now as soon as you put this pipe end in this manometer end, piezometer end in this pipe, this water will flow into the piezometer, right? Because there is a hole. When you put this, the water will rise, and it will rise to some extent, and it depends on pressure. If here is more pressure, here will be some height h, right, up to which this fluid has risen. If more is pressure, more will be the height, and if less is the pressure, so this will not rise too much, it will rise only up to this level. So therefore, with the help of this height, we can find the pressure. That's what we wanted. We will just measure how much this fluid has risen in this pipe. Okay, maybe this is calibrated, like here is written like 1 centimeter, 2 centimeter, 3 centimeter, and we will see directly. Okay, we will observe the readings and we can find the pressure in this pipe. And also we can find the pressure analytically, like I have mentioned here. The rise of liquid gives the pressure at that point. Okay, this is the rise of liquid, right, up to h height. Now say this liquid here right now, it is water. It is water, and the height is h. Here it has risen by height h. Then the pressure at A. Now the pressure in this pipe is rho gh, right? Pressure is equal to rho gh. I have already given the proof how the pressure is rho gh in the previous class. If you don't know, please go to the playlist of hydraulics, hydrostatics. I have mentioned these are in the first one and the two lectures. I have mentioned what is this, P is equal to rho gh. Anyways, it's really simple, rho gh, where rho is the density of fluid, g is the acceleration due to gravity, which is 9.81, and h is the water level. Okay, now here you can see P is equal to rho gh, means pressure is directly proportional to height. So more this height, more will be the pressure in this pipe. Okay, let's do some example. Find the gauge pressure at the center of the pipe carrying water, which is connected to piezometer. Okay, it is water. The rise of water level in piezometer tube is 3 meters. Okay, h is equal to 3 meters as shown below. This is really simple. How we are going to find this? Now see, pressure. Let me use another color, a thicker pen. P is equal to rho g h, right? Rho, this is water. So the rho is the density of water, is how much? 1000 kg per meter cube. G is acceleration due to gravity, G 9.81 multiplied by H. H is the height up to which the water level has risen in the piezometer, and it is 3 meters. Alright, so when you solve this, you will get the pressure in this pipe. Let's move on. Now the second type of simple manometer is U-tube manometer, right? Because as you can see here, I have mentioned piezometer. This is a simple manometer, right? Means we can find only pressure at one point. We have covered this piezometer. Now is U-tube manometer. Now U-tube manometer. The word itself says U-tube. What is this U? Means U shape, something like this, right? U-tube manometer. It consists of a U-shaped bent glass tube with another liquid of more specific gravity, generally mercury. One end of this tube is connected horizontally to the point where pressure is to be measured, and another end is open to the atmosphere. What it is saying, what exactly is a U-tube manometer? See, U-tube manometer is just this. Let me make just like this. Okay, this is the U-tube manometer, isn't it? Like U shape, right? This is U shape. Now it has again two ends. One end is this and another end is this. Now one end is kept open to the atmosphere. Here is atmosphere, right? Here is atmosphere. And another end, this end is connected to the pipe where we want to find the pressure. Okay, now here in this case we want to find pressure in this pipe, right? So this is the pipe, right? We connected it to the pipe, right? Now here is of course some fluid. Here is of course some fluid in this. Now as you connect it here, with the help of, you cut the hole, or there was some knob, this what you call that, there is already a hole which was locked. Now you remove the door of this hole and you put this one end to this. Now as soon as you put here, of course the water will go here, right, up to some level. That's why this is, because this is one type of fluid in this. When you cut the hole here, the water will come here. Now one thing is, in the U-tube manometer we have already another fluid. Okay, this fluid does not come from this one, it does not come from the pipe. Okay, this we always use one heavier fluid. Okay, like mercury is, like mercury, it is a heavy fluid, right? We know a specific gravity of mercury is 13.6, by the way, and uh, and it is considered heavier, so we put one heavy fluid, okay, already in this. Now since there is a hole in this and the water goes here, it will push the level. Wait, let me show you the first level like this. Suppose this is the mercury here, okay, up to this level. Now when you connect this to the pipe, the water will come and it will hit the mercury, right? It will exert some force on this mercury, so this level will go down and here the level will rise like this. Okay, now this way we can find the pressure in this pipe with the help of rise in this liquid. Actually there is a trick. I will show you one trick which is really important. Okay, it will help you to find pressure differences, the pressure in all type of problems. I am going to show you one trick and it will help you to find the pressure. Okay, I have mentioned here. So the trick is two rules. Okay, one rule is this: the pressure at all points on horizontal line is same if the fluid is same. the pressure at all the points on horizontal line. Horizontal line is, let me draw a line here with this color. Let me draw, suppose I'm drawing a line here, okay, like this. Now see, this is a horizontal line, and here is written the pressure at all the point horizontal line is same. Okay, the pressure on this line is same if, here is a condition, it's very important, if the fluid is same. Very important, if the fluid is same, the pressure is going to be same. Now see this horizontal line, here is one fluid at this point, so pressure is same. Here is same fluid, pressure is same. Here is same fluid, so pressure here is equal to pressure at this equal to this. Okay, the pressure on all these points is same because the same fluid. Okay, now here is different fluid, right? Because let's say if here is air, so here is air, so pressure at this point is not equal to pressure at this point. Okay, but pressure on these pointers on this horizontal line is same. Now if we are going to draw another line like this, oh, let me use the pencil. If I am going to draw a line, let me erase this one first. Now if I am drawing a line from here, see carefully. Okay, this is not a horizontal line, but please assume it to be a horizontal line. Okay, I just assume it's a horizontal line. Now see, because now see where is the same fluid, here is same fluid, here is same fluid, here is same fluid up to this point. So pressure from all these points, from here up to all these points up to here, the pressure is same. Now here is not the same pressure as this. Now here is another fluid, right? Here this is mercury, right? So the pressure at this point is not same as pressure at these points, right? Because although this is the horizontal line, but we are encountering a different fluid. Okay, I hope you understand. Now let me select another point. Now let me draw another line here. Let's say I will use another color. Let me use this color. Let's say I'm drawing a line here, a straight line here. Okay, assume this to be straight line. Now look at this point. Okay, try to carefully observe this point here. Okay, now this line is intersecting, is crossing through the intersection of this fluid and this fluid. Okay, but which fluid is here? Mercury, right? Here is mercury at this line. And which fluid is here at this interface? If you see the bottom of this line, it is mercury again, right? It is mercury. Although on the top is another fluid, but we don't care. We just, the same fluid have to touch the line. Okay, we don't care if it touches from the bottom or from the top. Here is mercury, here is mercury too from the bottom side. So on this line we have mercury, therefore pressure at this point, okay, if it is P, because this line is, here is mercury too, so pressure here is P again. Okay, now this concept is really important. Okay, now we have another rule too. We have two rules. Okay, believe me, when you will understand these two rules, they are really important. Okay, rule 1, you have understood, the pressure at all points on horizontal line is same if the fluid is same. Now we have rule number 2. Rule number 2 says as we move up we use minus sign. Okay, when we move up we use minus sign, and as we go down we use positive sign. what it is saying, if here is some point, okay, and you are going up from there, okay, so you will use negative. Up is negative. And if from this point you are going downwards, you will use positive sign, okay, positive. And here you will use negative. These two rules are very important. Don't worry, I will explain more this rule too, why, and I mean in what context I'm saying this. I think we should solve some problem, and okay, which will solve these problems. We will solve this problem to make you understand these two rules, okay. This problem is only to make you understand the two rules, okay. It is saying find the pressure of the fluid in pipe below. This is the pipe and it is containing water, and we have here in this pipe is mercury, okay. Now we have to find pressure in this pipe, okay. Let's say the pressure here is P, okay. Let the pressure here be P. We don't know, we want to find this P, right? Now see, if you draw a horizontal line from here to here like this, if you are drawing a horizontal line, okay. Now if the pressure here is P in this pipe means the pressure here is P also, right? Means the pressure here is P also, means the pressure here is P too, right? Because this is the same fluid on this horizontal line. Here is water, here is water too. Therefore pressure here is P again. So we write P, okay. Now we don't have to go up, right? Because here is nothing. The pipe is going downwards, so we go downwards. Now going downwards, we reach this point, right? We reach here. Because we were actually here the pressure is P, we wrote the P here. Now we are going down from this P pressure, we are going down, right? This is down like this. We will use we will use positive sign plus. Now how much is the pressure here at this interface? Pressure here is pressure at this plus rho g h, rho g h here is 8 centimeter, right? This is 0.08 in meters, right? We find first P here, then we go down, we use positive sign. Now where are we? We have reached here, interface, okay. Now here is a trick. We don't have to go more down. I mean, we don't have to go here and here and here. You know why? Because here in this interface is mercury, here is mercury too, right? In this line, on this line, here is mercury and here is mercury. Because here is mercury and here is mercury too, whatever the pressure is here, right? Whatever the pressure is at this point, same pressure will be at this point too, right? So we will skip these things, okay. We will just make a move towards the right. We will not go down because pressure at this point is pressure at this point, actually at this point. So we are here, right? Because this is the, all of this is the pressure at this point, right? But since it is the same fluid on this line is the same fluid, therefore how much is pressure here is the same here. So this, all of this is also the pressure here, which literally means we are here now, right? Now from here we have to go upwards, right? Now I have told you the rule, when you go upwards you use the negative sign, okay. We will use negative. How much is the, we are going from here to here, so this one is our height, right? H minus rho, but which fluid is this? This is mercury, right? So rho g, I mean say density of mercury, rho g H is 20 centimeter, which means 0.2 meters. Okay, now here we came from here to here. Now we are here, right? Now above this is atmosphere, right? So when we calculate the gauge pressure, we equate this pressure to 0. So this, all of this is equal to 0. Why? Because here is atmosphere, right? Now we can find this P here, right? Now P, if we do these terms to the shift these terms to the right side, we get P is equal to rho mercury G into 0.2 minus density of water multiplied by G multiplied by 0.08. Okay, now here is pretty simple. Now density of mercury is how much? Rho G. We know density of mercury is the specific gravity of mercury, right, multiplied by density of water, and density of specific gravity of mercury G is 13.6 and density of water is 1000. So we get 13600. We'll get here density of mercury how much? 13600 multiplied by G is 9.81 meter per second square multiplied by 0.2 minus, now this rho is density of water, which is 1000 multiplied by 9.81 multiplied by 0.08. Okay, don't worry about the notes. I will provide the link in the description. You can download my notes there. Just try to understand right now. Okay, oh, here we go. When you will solve this equation with the help of a calculator, let me use a calculator and I will tell you the pressure in this. Okay, I find the pressure to be 25898 25898 Newton per meter square, which is equal to 25898 Pascal, right? Because 1 Pascal is equal to 1 Newton per meter square. Okay, all right, so this is the pressure in the pipe. Now that's what we wanted. Okay, find the pressure of the fluid in the pipe. So we found it. So here was a trick which I used. I hope you understand it. When you go up from a point, you use negative sign, and when you go up from a down from a point, you use positive sign. That's why I have used here. I have assumed the pressure in the pipe where I want to find the pressure be P. Okay, so here is the same pressure P. Now I'm going down, so I'm using positive, right? This is positive, and here is rho G. This is 8 centimeter from here to here, which is 0.08 meters, and I have reached this point because this is the same mercury in the both of two, so I have reached this point too. From here I am going up, so I am using the negative sign minus rho, because this is the mercury, density of mercury G into H. H is 20 centimeter, which is 0.2. Okay, so you have understood these two rules. Okay, the pressure at all the points on horizontal line is same if the fluid is same, right? If the same fluid, and as we move up we use minus sign, and as we go down we use positive sign. All right, I hope you understand. Now let's move on. Now let's move on to the differential manometers. Okay, now as the word differential means, we have to find the it will be helpful to find the pressure difference between two fluids, okay, or 2 points. So we can find PV minus PA or PA minus PB with the help of differential manometers. That's what is written here, to find pressure difference between 2 points. Okay, now differential manometers are of 2 types. One is this U-tube and another is inverted. There is U-tube, inverted U-tube differential manometer. Okay, I have already told you U-tube is something like this or this. You will find many shapes or the same exact capital U. Okay, anyways, these are all the U shapes, and the inverted U-tube is like this or this or this. Okay, these are all the inverted U-tube manometers. The basic difference here between the two is we use first of all we keep it like this. Okay, we right upright, and this one is inverted. This is the first difference, and the difference is here we use an inbuilt fluid which is heavier. Okay, its density is more than the fluid we are trying to find the pressure difference. Okay, here we use heavier fluid, but here we use lighter fluid. This is the basic difference. Okay, now this inverted one is used to measure the low pressures, and this straight upright U-tube differential manometer is used to find the higher pressure difference. Anyways, let's move on. Differential manometers are used to find the pressure difference between 2 points. Okay, pressure difference between 2 points. It consists of a U-shape bent pipe with a heavier liquid. I have told you here we use heavy liquid here. To find the pressure difference between two fluids, the two ends of differential, this GM means differential manometer. Okay, differential manometer are connected to those fluids. Now in earlier I have connected only, let me show you here. Now this was a simple U-tube manometer. Now one end here was connected to the pipe and another was kept open to the atmosphere, right? But in the differentials we keep this, we don't keep it open to the atmosphere. Okay, we also connect it to the another fluid. Why we are doing that? Let this be B and this be A. But why are we doing that? Because we want to find the pressure difference between A and B, and it's only possible when we connect both of its two ends, right? One end with this A and another end with this. In this way we will find the pressure difference, and let me show you how. Let me show you. I think we need an example. Okay, I have very clearly mentioned here U-tube differential manometer. Okay, now this is our manometer, right? This is our manometer. This is our manometer. It has one end, it is connected to this pipe, and this is another end, it's connected to the this pipe. Okay, no end is open to atmosphere, both the ends are connected to the pipes because we want to find the pressure difference between A and B. Okay, now in this is a heavier fluid, right? Now you see, if now when you have connected this pipe to this, right? First here it was closed. Now when you open it like this, water will come. Also here was closed. When you will open it, this fluid, or this may not be water exactly, this can be any fluid. The thing is that they are lighter fluids. Okay, I mean say their density is not as that of this mercury or heavier fluid. Anyways, when you open here, the fluid will come and it will push it downwards. Okay, when you will push it downwards, right, so here it will go upwards. Okay, now if this thing have more pressure, okay, here is pressure more, now this force will be more, right? So this would be like something like, it would be like something like this. Okay, let me show you this level. It could be something like this. Okay, this would go more down, right? Because if this have more pressure, so more force here, so this level which I have shown here actually would go somehow like this, down, and here the fluid will go up. Okay, now what does this diagram say to you? If I ask you question, which pipe have more pressure, what are you going to answer? You see the fluid, you see here, if you draw the line here, the mercury has risen here, okay? It means the net force is more here, right? Because that it has, because basically the horizontal level is this. If the pressure at A is equal to pressure at B, then this here would be no rise, okay? It would be only up to this point, okay? Up to this point. Let me use another color, something like this, okay? Because here, if this is the, okay, I have connected them to the fluids here. This is A and this is B, okay? Now if PA is equal to PB, the level of mercury would be same, right? On this line, right? The level would be the same here and here. Now if PA is more than PB, now PA is more than PB, what would happen? Let me draw a diagram very fast, something like this. This is A and this is B. Now if PA is more than PB, means if we draw a horizontal line here, okay, now the level of mercury would have been like this, something like this, right? Now if PA is less than PB, PA is less than PB, I will write it here down. Let me draw a diagram, rough diagram real fast. This is A, this is B. Now PA is less than PB, it means PB is greater than PA. So here would be, because this is PB, here would be more downward push, so the level would have been like something like this, okay? Now anyways, this was just some important points which I wanted to tell you about the pressures. Now let's basically, what's more important is the two rules, okay? These two rules which I have mentioned here. Oh, it's these two rules, okay? These two rules are very important, and it doesn't matter which manometer you use. It doesn't matter if you want to find the pressure at one point using simple manometers, or you want to find the pressure difference between 2 points, okay? Always we use these two rules and we get our answers, okay? Those two rules are very important and they are universal, they apply everywhere. Now let's solve this problem. Find the pressure difference between two fluid pipes as shown below. Okay, we have to find the pressure difference. Okay, let's call here, let the pressure here be PA in this fluid, and let the pressure here be PB in this fluid, right? We have to find the PA minus PB, or PB minus PA is the same thing. Now we are going to use a trick, okay? Now see, as we draw this horizontal line here, because this is the same fluid, if the pressure in this pipe is PA, so at this point pressure would be PA2, okay? Now we are at this point, right? Now let us write this equation. PA, where are we? We are here, right? Because we have already traveled from this pipe to this. Now the pipe is going down, and means we are going down, okay, up to this interface, okay? Because here here is mercury, right, and here is mercury too. So we will only go up to this point, but we are going down means positive plus this is water, right? So rho density of water G multiplied by H. What is H here? 2 meters. 2. Okay, we are here. Now since the pressure here is same as pressure this, so we can just uh, shift to this pipe, right? Because this is the same fluid here. Now basically we are here, right? Now from here what we have to do, we have to go upwards because we have to go towards PB. We want to find PA minus PB. We have PA and we have to go towards PB, right? We were here, now we are going upwards 3 meters, right? Means negative. Upward means negative, right? Negative. So we'll use negative. Now this is mercury, right? This is mercury, right? See, mercury, density of mercury, let the mercury be denoted by Hg or G, rho G multiplied by 3, right? We are here now, right? Now we have to go more upwards up to this point, right? So from here to here is 4 meter, but it is upwards, right? So we will use negative sign. Minus rho, we don't know what this is. Okay, yeah, we know this is a fluid whose specific gravity is 0.8, but we don't know its density. We will call the density of this B rho B, okay, because this is fluid B, rho B, and this one is fluid A. We'll call this as rho A, and A is water, right? And rho B, G multiplied by G multiplied by H. How much is H? 4 meters. Now tell me, where are we? We are here, right? Now if you are going to draw a line here, you see here is same fluid, fluid B, here is fluid B, here is fluid B, here is fluid B, until we reach the pipe inside. Because they are the same fluid, so pressure at this point is same as pressure at this point, okay? Means we have reached here is equal to PB, right? Pressure at B. In the previous case, because here was no pipe, this was open to atmosphere, so we had equated this basically to 0, right? But we will not write 0 here, we will write PB, right? Because here is no atmosphere, this was because of atmosphere, right? 0. But here is, do you see any atmospheric here? Atmosphere? No. Here is fluid B, so of course here will be PB instead of 0. That's why I have equated all of this to pressure at B. Now you can write, you can move this to left, we get PA minus PB is equals, you can move all of these terms to the right. What we get, this would be negative, okay? We will write it in the last. So first is this rho Hg means mercury multiplied by G multiplied by 3 plus density of fluid B multiplied by G multiplied by 4, and this term will be negative on right side, right? Density of A multiplied by G multiplied by 2. Here we go, we found the pressure difference PA minus PB. Now here we will put density of mercury. What density of mercury is specific gravity of mercury, which is 13.6 multiplied by density of water, okay, which is 1000. So 13.6 multiplied by 1000, it will be 13600. So density of mercury 13600 multiplied by G is 9.81 multiplied by 3 plus, now again density of B would be what? Density of B would be what? Density of B would be specific gravity of B multiplied by density of water. Now how much is the specific gravity of B? It is 0.8. 0.8 multiplied by density of water is 1000, this would be 800, right? So here the density is 800 multiplied by 9.81 multiplied by 4 minus rho A. Now A is water, I think. Yes, A is water. Okay, so here is water whose density is 1000 multiplied by 9.81 multiplied by 2, right? Okay, now this is PA minus PB. Now we are going to solve this PA minus PB. We are going to use the calculator to find all of this. Let me use the calculator. I found pressure difference between these two to be 4122020 Newton per meter square, or PA minus PB is equal to 412020 Pascal, which is equal to 412, approximately equal to 412 kilopascal, right? So here we go, we find the pressure difference. Okay, again we have used only those two rules, right? Those two golden rules. Now let's talk about inverted U-tube. Differential manometer, I have already told you inverted manometers are something like this, or like this, or like this, things like that. We use lighter fluid, okay, because the differential manometers have already one inbuilt fluid, right? As we have seen in the U-tube differential manometer, there was heavier like mercury, but in inverted one we will use something whose density or whose specific gravity is lower than the fluids we want to find the pressure. Okay, the word differential indicates that it is used to find the pressure difference between two fluids. Okay, as I have said, this differential means it is indicating that we are going to find the pressure difference. Okay, this is same. Now inverted, this we have an example of this inverted U-tube manometer, and believe me, it is same as before. The what you call that is those manometers, right? Differential manometers, U-tube differential manometers, and the rules are the same. Okay, the two rules, they are going to help us all the time. Okay, now what's asked here? Find the pressure difference between pipes A and B. Okay, here is A pipe and here is B pipe. In A pipe is water and B pipe is water too, right? Both containing water and are connected to an inverted U-tube manometer containing a fluid of specific gravity 0.8. Okay, the inbuilt fluid of this inverted manometer has a specific gravity of 0.8, right? Find the pressure difference between A and B. So we have to find PA minus PB. Let me solve here. Here is the solution. Now let's use the rule. First we have to begin from any pipe. Let's begin from A pipe. So we write pressure at A. Okay. Now where is the interface? We are moving upwards, right? So negative. Up to which point we are going to move? We are going to move up to this point, right? Why not up to this point? Why not up to this point? Because see, here is one fluid, right? See this, see the top side of this. Here is this light sky blue, right? And this line, if you go, here is sky blue, I mean the lighter fluid too. Here is the same fluid. Why we have to move here and here? We don't need. We will move up to this. We will automatically reach to this point, right? Because here is the lighter fluid and here is the lighter fluid on this horizontal line too. Means pressure here is same as pressure this. Okay, that's why we will move from here upwards only up to this point. From here only up to this point, not up to this point or this point. Okay, then we will move to the right. we will reach this point because here is same pressure on all this line. Then we'll move downwards until we reach B, right? Because we had to find PA minus PB. PA we get from the beginning, and we had to move like this, then like this, then downwards until we reach B. Okay, so let's begin. Now PA, now here we are here, now we are moving upwards up to 35 centimeters, right? So we are moving upwards means negative, right? This is water, density of water multiplied by G multiplied by H. How much is H? 35 centimeter, which is 0.35 meters. 0.35. We have reached this point, right? Now here we will move to the right because here is lighter fluid, here is lighter fluid too, means same pressure here, same pressure here. So we have reached here, right? Now from this point we are moving downwards up to this point, means we are moving downwards means positive, plus oh plus, now this is lighter fluid, right? It would be G rho W, rho, this is all rho, density of lighter fluid multiplied by G multiplied by H is 30 centimeter, which is 0.3, right? And this G is 0.8, right? Because here is 0.8. Now we are here, right? Now from here we are moving downwards. Again we are moving downwards means what? Means positive, right? When we move downwards we use positive, when we move upwards we use negative. Now we are moving from here to here. The H height is 35 centimeter, which is 0.35 meters. So we will use again plus sign, plus. Now this is water, right? From here to here this is all water. Okay, rho means density of water multiplied by G multiplied by 35 centimeter is 0.35 meters. Okay, now where are we? We are here now. Will we equate this to 0? No, because here is no atmosphere, right? Here is PB, so we are going to write is equal to pressure at B. Now if you rearrange the terms in this equation, we get PA minus PB. Okay, I get this to this side would be, now this term would be positive on the other side, rho G 0.35. this is positive, it is going to be negative. Okay, G rho W G multiplied by 0.3. this term is positive, it is going to be negative on another side, right? Now PA minus PB is equal to, now this is rho, it is density of water is 1000 multiplied by G is 9.81 multiplied by 0.35, all of these things minus, now this G is 0.8, right? 0.8 multiplied by density of water is 1000 multiplied by 9.81 multiplied by 0.3 0.3. now this minus this is again water, this is 1000 multiplied by 9.81 multiplied by 0.35. so when we solve this equation we will find PA minus PB. Let me use a calculator. Also you can also practice with me and see if we get difference in the answers. If we get difference you can tell me. Okay, I have solved this. I found PA minus PB equals to minus 2354.4 Newton per meter square, or we can write PB minus PA is equal to 2354.4 Newton per meter square is pascals, right? So there we go, we found the pressure difference, right? So that's it for this class. Again, you are going to find the notes on this lecture. You can download them from the description or in the comments. And if you have any problems, please you can contact me in my email or YouTube or Facebook. You can ask me the problems and I'm going to help you definitely. So see you in the next class. Thank you.